Hello and welcome to our demo at the ORAN Alliance face-to-face meeting in Rome in February 2026. We will be showing the energy saving use case implemented using open source functions. And this work is brought to you by a wide range of people, including from the ORAN SC project, the Open Cells project, the Open Air Interface Software Alliance and the Duranta project, and from the Cosmos Lab. So on the top left, you will see the some measurements that are gathered over O1PM. So you'll see throughput and the number of connected UEs in a given cell collected from an ODU. On the bottom left, you will see some configuration interfaces using the ONAP SDNC functions represented here using the ODL UX front end. And on the top right, you will see the energy usage of the Benatel ORU function. So first of all, we kicked off and started the Duranta RAN functions and the OAI core network. Okay. So you will then see now that the RAN nodes and the core is ready, and our SMO functions are waiting for some O1PM data to be collected from the ODU. Okay, so once we see that some PM data has been collected over the O1 interface, we will now connect a UE to the RAN. So it takes a little bit of time for some data to arrive, but soon afterwards, we will now see that the UE has become connected and some PM data has been collected from the ODU. So you will see that currently the throughput in the cell is still 0, but you will see also in the graph that there is one connected UE collected as a metric from the DU. So now, in order to create some traffic, we will kick off a job in the UE, which essentially creates an iPerf job. So this basically shows some traffic being communicated to and from the UE over to the DU. Okay, so on the top left, you will see that we're starting to see a spike in measured traffic in the cell, and we see the throughput measurements have increased, and also at this time you will see in the top right graph that once traffic starts to flow, that increases the energy usage in the ORU. You will see that we have spiked to 71 watts being used by the ORU. This is up from a steady state of 62 watts in the ORU. So now that we have some traffic flowing, we will start an RAP in our SMO. So first we will basically onboard the RAP. So we will upload the CSAR file containing the RAP. Once we have onboarded the RAP, we can then prime the RAP, which essentially gets it ready for instantiation. Okay, and then we create a first instance of this RAP. You'll see each step that we do a get after each, just to show the effect of the previous operation. Then we deploy this RAP instance. So at this stage, the RAP should start running. So we go to our friendly Kubernetes interface here, and we see that we find the pod that represents the RAP. So this RAP essentially enables or disables the energy saving functionality in the ORU. Okay, so now we have found our pod. We see that our RAP instance has been created. So now we can check the logs for this RAP instance microservice. So this RAP essentially waits and checks how many connected UEs there are for a given cell. And if that number drops to zero, it will then essentially put the ORU into energy saving mode. Okay, so we still see that there's traffic being carried using the UE. So we first stop the UE. So we disable the load generation function, and then we stop the UE. So this essentially disconnects the UE from the ORU. And you will see in the graphs in the top left that the throughput value being reported from the DU has now started to decrease and will eventually drop to zero. And you will also see that the number of connected UEs in the second of the top left graphs will also drop to zero. At about this time as well, you should start to see that the energy usage of the ORU should drop back to its standby level, which is approximately 62, 63 watts. Okay, there we go. And we see in the graph, as expected, the throughput value being reported by the DU for that cell has dropped to zero. Now we see the UE disconnecting. And in a moment, we'll see this connected UE value drop. So at this stage, the network is operating as normal, but there are no connected UEs and no traffic over the cell. You can see in the bottom left that the energy saving mode for the RU is currently false. So the RAP detects at this stage that there is no UE, and it enables the energy saving mode in the RU. For demo purposes, we have configured our RAP to re-enable the RU, or essentially disable the energy saving mode in the RU after 2 minutes. This is only intended as a demonstrator. In the real world, you would have more complicated logic to determine when the RU should be enabled or disabled. So at this stage, you can see that energy saving has been enabled in the RU. You will also see a substantial drop in energy usage in the RU. So at this time, it drops to 52 watts being used by the RU. So after a timeout, the RAP disables the energy saving mode in the RU again, the RU. Then just to confirm, we will check the configuration of the ORU in the bottom left, and you will see that the energy saving mode has been disabled. At this time as well, then you will see the energy usage by the ORU jumps back to its normal standby level of approximately 63 watts. So just to show that the ORU and the cell is now ready and able for traffic again. So we start the UE again. Soon we will see that the connected UEs metric in the top left returns to 1. Okay, we will create some load again from the UE. So this generates some traffic from the UE to and from the network, essentially loading the ORU. At this time, you will hopefully in a moment see the energy usage increase again in the ORU in the top right. You will also see again the throughput values being reported for uplink and downlink. In the top left, jumps again. So we killed the data generation load in the UE, and now we're going to stop the UE again. So the UE disconnects from the ORU. The RAP detects that there is again no UEs connected to the ORU, and again will start to put the ORU in energy saving mode again. So we will, just to verify, check the configuration of the ORU, and we now see that the energy saving mode has been re-enabled. We will soon see a drop again in the energy usage in the ORU, represented in the graph in the top right hand side. So we see that the ORU energy usage again drops back to its energy saving level of 52 watts. So the RAP continues to run. It re-enables the ORU by disabling its energy saving mode periodically. UEs can then connect to it, create traffic, disconnect. And as again, once the RAP detects that there is no UE connected, it will again put the ORU back in energy saving mode. Of course, this use case is quite contrived and very simplistic, and real world use cases will of course be a lot more complicated, but this just shows the concept. Thank you.